Hi everyone, my name is Hanlin, and I'm gonna do the question 2 of homework 3, so let's begin. For the subproblem A, it has to find the density function and the distribution function of x. It's pretty simple because it tells us that x is a uniform distribution from A to B, so we can directly write the density function as it equals to 1 divided by b minus a when x is larger or equal to a and smaller or equal to b, and it equals to 0 when x is otherwise. So, and then we will find the distribution function of it. So when we know when x is smaller than a, it definitely equals to 0. And when x is larger or equal to a and smaller than b, we can calculate the integral of its density function from a to x. So it is equals to x minus a divided by b minus a, and we know when x is larger or equal to b, then the value of its distribution function is 1. So we write it as integrated. So the distribution function is equals to 0 when x is smaller than a and is equals to x minus a divided by b minus a when x is larger or equal to a and smaller than b, and is equal to 1 when x is larger than or equal to b. So we draw the density function like as this from a to b, and the value is 1 divided by b minus a, and it equals 0 when x is larger than b or smaller than a, and the distribution function is when x is smaller than a is 0, when x from a to b it is linear from 0 to 1, and when x is larger than b, then it stays at 1. So that's the subproblem A. And for the subproblem B, it gave us that a is equals to -1, b equals to 3. So it has to find and draw the distribution function and density function of random variable y, and also find the expectation of y. So first we will find the density function of y. But for this subproblem, we have to discuss the at y's value, because when the value of y is different, we will have the different situation, and we will have to calculate the density function in a different way. But generally speaking, it uses the fundamental theorem. So first, for 1 is larger than 0 and smaller than or equal to 1, we can derive that y equals to x squared, and from that we can derive x equals to, it's either square root of y or minus square root of y. So it has 2 roots. So we have to use the fundamental theorem with 2 roots situation. So the density function of y is equals to the density function of x when x equals to x1 divided by the derivative of gx1 and the absolute value of it, and plus density function of x when x equals to x2, and the density divided by the derivative of gx2 and the absolute value of derivative of gx2. So we substitute the x1, x2 into it. We can just suppose x1 equals to minus square root of y, and we can suppose x2 equals to square root of y. So we have this equation, and finally equals to 1 divided by 4 times square root of y. And for another situation, when y is larger than 1 and smaller or equal to 9, we have y equals to x squared, but when y is at this range, x can only equals to square root of y, because when y is larger than 1 and smaller than 9, that means that x is larger than 1. So in this situation, x equals 0, so we can only have this root, like square root of y. That's the only value that's the only root of x. So still we use the fundamental theorem, the density of the function of y equals to density of function of x root, and divided by the absolute value of the derivative of gx. So still we substitute the value into it, and finally we can derive that equals to 1 divided by 8 times the square root of y. So generating the density function of y, we have the density function of y equals to 1 divided by 4 times the square root of y when y is larger than 0 and smaller than or equal to 1, and we have it equals to 1 divided by 8 times the square root of y when y is larger than 1 and smaller or equal to 9, and of course this equals to 0 otherwise. And then we calculate the distribution function of y. Is this the integral of the density function from minus infinite to y, and of course when y is smaller than 0 to 0, and when y is larger than 0 and smaller or equal to 1, and this is the derivative of 0 from y, and we can just substitute y into it. And when y is larger than 1 and less than or equal to 9, it is we have the distribution function of y equals this, and we calculate it, and finally we can get the result like it equals to 0 when y is smaller or equal to 0, and it is equal to 1/2 times square root of y when y is larger than 0 and less than or equal to 1, and we have 1/4 times square root of y plus 1/4 when y is larger than 1 and smaller or less equal to 9, and equals to 1 when y is larger than 9. So it has the joint, so the figure is like this. We just simply draw different interval of y's numbers. So we have these two figures, and finally it tells us to find the expectation of y. So we just use the definition of the expectation. It is equal to integral from minus infinite to infinite y times the density function of y, and we divide it into different parts. First is the from interval of 0 to 1, and second is the interval of 1 to 9, and we substitute the density function to it, and we calculate step by step, and finally we get the result is 7 divided by 3. So that's the final result of the expectation of y, and that's all for the question 2. Thank you.